Good afternoon to all. Here we have started the differentiation of composite function in 2 variables and 3 variables. So let us see. Z is equal to f of xy possess continuous first order partial derivatives and let x is equal to phi of uv and y is equal to phi of uv, or you can consider here it psi of uv. Okay, then x and y possesses a continuous first order partial derivative. Then partial derivative of this z with respect to x and y, as well partial derivative of this z with respect to u and v is given by chain rule. That is, here z is function in x and y, where x and y, these are the functions in u and v. Obviously, this z is called as a composite function. So, taking derivative of this z with respect to u and v partially. So, dou z by dou u is equal to, how we are taking that? Dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. Look at this. Z is function in x and y, where x and y, these are the functions in one variable, that is u. Later on we are taking that v. Okay. So first we are taking that dou z by dou x, then dou x by dou u. Here it is dou z by dou y, and here it is dou y by dou u. So we are taking derivative of this z with respect to u. It is dou z by dou u. So dou z by dou u, by using chain rule, we are getting as dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. Similarly, if I am taking the derivative of this z with respect to v. So here z is function in x and y, where x and y, these are the functions in v. We have to take the derivative of this z with respect to v. By using chain rule, it is dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. So right here, partial derivative of z with respect to v is equal to dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. Okay, if z is function, just I am taking that z now. Z is function in, or I will take that v. इथे या ठिकाणी दुसरे घेऊयात function. Phi घेऊयात आपण. Phi is function of x, y, z, where x is function in psi of u, v, w. Y is function in psi of u, v, w, and here z is function in psi of u, v, w. Means here we have 3 variables. Now I am taking derivative of this phi with respect to u, v, w. Derivative of this phi with respect to u, v, w by using that chain rule. How we are writing here? Look at this. Phi is function in x, y, z, where x, y, z, these are the functions in u, v, w. First one. Second, again this phi is function in x, y, z, where x, y, z are functions in v. Then again phi is functions in x, y, z, where x, y, z, these are the function in w. So I am taking that derivative of this phi with respect to u. Tell me that how we are taking by using chain rule. Dou u by, sorry, it is dou phi by dou u. Dou phi by dou u is equal to, how we should take that? Yes, anyone? By using
Dou
chain rule?
x upon dou u.
First, dou
Dou
phi
phi upon
by
dou x. Dou x.
dou x. Yes, correct. Into dou
Dou
x
x
by
by dou u.
yes,
Dou x by dou u.
plus go with this y,
Dou phi by dou u into dou u by
dou
y
phi
by
by
dou u.
dou y into dou y by dou u plus dou phi by dou z into dou z by dou u. First one over. I complete first. Now going for the second. Partial derivative of this phi with respect to v by using chain rule once again. So it is dou phi by dou x into dou x by dou v plus dou phi by dou y into dou y by dou u plus dou phi by dou z into
Dou v ma'am.
v येतं इथं. त्याच्यानंतर dou z by dou v. And lastly, we are going for the third one. Partial derivative of this phi with respect to w. So dou phi by dou w. Dou phi by dou w, it is equal to dou phi by dou x into dou x by dou w plus dou phi by dou y into dou y by dou w plus dou phi by dou z into dou z by dou w. So here we can take the partial derivative of that phi with respect to u, v, w by using chain rule like these. Everyone understood this?
Yes ma'am.
Okay. प्रत्येकाने हे जे काही ह्या टाइपचे म्हणजे नोटेशन केलेलं आहे हे मुद्दाम केलेलं आहे बरं, म्हणजे आपल्याला इझी वे मध्ये समजून जातं तिथं. इट इज बेसिक. ओके. Now let us start to solve examples related to this composite function, partial derivative of composite function in two variables. Okay. So first example I am writing here. If z is equal to f of uv and u is equal to log of x square plus y square, where v is equal to y divided by x, then show that x into dou z by dou y minus y into dou z by dou x is equal to 1 plus v square into dou z by dou v. What is given and what we have to find out. Just make it clear first. Okay. So here z is function in u and v, where u and v are functions in x and y. Therefore, z is composite function in x and y. So u is equal to, we have log of x square plus y square, where v is given y divided by x. So first of all, we have to find out derivative of this z with respect to x by using chain rule. So write that dou z by dou x. Z is function in u and v, where u and v are functions in x and y. So taking derivative of this z with respect to x first. Dou z by dou x. Dou z by dou x is equal to dou z by dou u into dou u by dou x plus dou z by dou v into, is it correct?
Yes, ma'am.
Is it correct?
UV.
Correct or
No,
wrong?
ma'am.
Yes, it is correct.
Correct.
Because I am taking
Correct,
derivative
ma'am.
of z with respect to x, where z is function in u and v. Where z is function in u and v first taking with respect to x. And z is function in u and v, again u and v are functions in y. त्याच्यानंतर second part कडे जातोय आपण. So here it is dou v by dou x. Got it? Similarly, taking derivative of this z with respect to y is equal to dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. Just let me know हा dou z by dou x आणि हा dou z by dou y कसं आपण लिहिलेलं आहे हे सगळ्यांना समजलं?
Yes,
Is it clear to all?
Yes, ma'am.
yes, ma'am.
Earlier I have taken like this. Look at this. या टाइपचे तुम्ही हे फिगर काढायची अशी या फिगर नुसार तुम्हाला इझी कन्सेप्ट म्हणजे तो कन्सेप्ट क्लिअर होऊन जाईल. फंक्शन्स काय आहेत आपले? z is function in u and v are functions in x and y. So according to that, by using chain rule, we will get these two terms. Okay, these two partial derivatives. Now we are going to find out that derivatives. So calculating dou z by dou x is equal to derivative of z with respect to u. Just I am keeping as it is first. Dou z by dou u. Because here z is given as f of uv. So just we have to keep as it is. And later on we will find out. Next, dou u by dou x. Derivative of u. What is u? Log of x square plus y square. Log of x square plus y square. So find out that derivative of u with respect to x. So 1 upon x square plus y square into 2x. Okay, plus again this dou z by dou v keeping as it is into derivative of z with respect to derivative of v with respect to x. So it is minus y upon x square. It is partial derivative, isn't it? So simplifying the term, or just I am writing once again the same term as 2x upon x square plus y square into dou z by dou u plus it is minus y upon x square into dou z by dou v. ठीक है? Suppose this expression we are taking as a first expression. In example, what we need? Y into dou z by dou x. So multiply equation 1. Multiply this given equation 1 by y. Okay. Therefore, we have y into dou z by dou x is equal to 2xy divided by x square plus y square into dou z by dou u minus y square upon x square into dou z by dou v. I will make it as a star equation. Okay. After that, finding out derivative of z with respect to y. So take out the derivative of z with respect to y again with chain rule. So it is dou z by dou u into derivative of u with respect to y. It is 2y divided by x square plus y square. What is u? U is given log of x square plus y square. Differentiate this u with respect to y keeping x constant. So 1 upon x square plus y square into derivative of y square, that is 2y plus dou z by dou v as it is. Taking derivative of v with respect to y, it is 1 upon x. And here suppose it is second equation. Now multiply equation 2 by x. x ने multiply करते हैं. So x into dou z by dou y is equal to 2xy divided by x square plus y square into dou z by dou u plus x upon x, that is 1. 1 into dou z by dou v, and this equation I am taking as a double star. Now subtract star equation from double star. So subtracting star from double star. Okay. Now next, right there. Therefore, x into dou z by dou y minus y into dou z by dou x is equal to double star मधनं star minus करायचे. So first write that double star 2xy divided by x square plus y square into dou z by dou u plus 1 into dou z by dou v minus first equation, that is star equation. It is 2xy divided by x square plus y square into dou z by dou u minus y square divided by x square into dou z by dou v. Simplifying the term, x into dou z by dou y minus y into dou z by dou x is equal to 2xy divided by x square plus y square minus 2xy divided by x square plus y square into dou z by dou u plus in bracket 1 minus into minus becomes plus 1 plus y square divided by x square into dou z by dou v. For this bracket we are getting 0, and lastly we are getting that 0 into dou z by dou u, that is 0. So here it is 1 plus y square upon x square into dou z by dou v. But as we know that y square upon x square, because y upon x is given v. So in that case, we can put that y square by x square as v square. So 1 plus v square into dou z by 2. Hence the proof. Okay. Everyone understood this?
Yes, ma'am.
Yes, ma'am.
Is there any
Yes,
confusion
ma'am.
to solve
No.
this example?
No, ma'am.
Once again, take a look on this. How we have solved. What is given. What we have to find out. How we are taking derivative of that given functions. How to add, how to subtract. And finally, we are getting that result. Now, next example. Second. If z is f of xy, where x is equal to e raised to u into cos v, y is equal to e raised to u into sin v, then show that x into dou z by dou v plus y into dou z by dou u is equal to e raised to 2u into dou z by dou y. Given z is equal to f of xy, where x is equal to e raised to u into cos v, y is equal to e raised to u into sin v. Then we are taking derivative of z with respect to v, derivative of z with respect to u. By using chain rule, taking derivative of z with respect to u is equal to derivative of z with respect to u. How we are taking that? Partial derivative of z with respect to u by using chain rule. It is, yes, dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. Similarly, taking derivative of z with respect to v, it is equal to dou z by dou y into dou y by dou u plus dou z, the x sorry. So here dou z by dou x into dou x by dou v, dou z by dou y into dou y by dou v. Partial derivative of given function. So it is dou z by dou u is equal to dou z by dou u is equal to. Tell me derivative of z with respect to x. Just put it as it is. There is no any change. Okay. So dou z by dou x into partial derivative of x with respect to u. x with respect to u. That is e raised to u into cos v plus dou z by dou y into partial derivative of y with respect to u. It is also e raised to u into sin v. Okay. Then taking derivative of z with respect to v, which is equal to dou z by dou x. All are getting my voice clearly?
Yes, ma'am.
Yes, ma'am.
Dou z by dou x into derivative of x with respect to v. Yes, it is minus e raised to u into sin v. Because we are taking e raised to u, that is constant term, and taking derivative of cos v, that is minus sin v. Plus, again put that dou z by dou y as it is. Taking derivative of y with respect to v again. So once again e raised to u into derivative of sin v, that is cos v. What we need here? X into dou z by dou v. So multiplying this dou z by dou v with x. So x into dou z by dou v is equal to x. I am writing that first x as it is. Later on we will change that. E raised to u into sin v dou z by dou x plus x into e raised to u cos v into dou z by dou y. Suppose here it is first equation. Then multiply this dou z by dou u by y. So y into dou z by dou u is equal to y into e raised to u cos v into dou z by dou x plus y into e raised to u sin v dou z by dou y. Suppose this as the second expression. Adding 1 and 2. Adding 1 and 2. And here in first expression and second expression, on right hand side we should put the value of x. What is x? E raised to u into cos v. What is y? E raised to u into sin v. So here we can write as x into dou z by dou v plus y into dou z by dou u is equal to, put the value of x, value of x,
E raised to
to
u
u into cos v, correct. So minus e raised to u into e raised to u, it is 2u into sin v into cos v, sin v into cos v into dou z by dou x. Okay, plus just I am taking only first term here, replacing this x and x with e raised to u cos v plus x into e raised to u cos v, that is e raised to 2u into cos square v dou z dou y. After that, here it is the first term plus going for next term y, that is e raised to u into e raised to u, that is e raised to 2u sin v into cos v, sin v into cos v dou z by dou x plus again e raised to u into sin v into e raised to u sin v. So it is e raised to 2u sine
square
square v.
v.
Dou z by dou y. Now here it is enough to understand. One term is negative, one term is positive. There are these two terms are same, but one is negative, one is positive. So these two terms will get cancelled. Remaining two terms are there: e raised to 2u into cos square v dou z by dou y, e raised to 2u into sin square v dou z by dou y. And if you are taking that e raised to 2u into dou z by dou y as a common term, in bracket cos square v plus sin square v, it gives 1.
1.
Yes, correct. Therefore, x into dou z by dou v plus y into dou z by dou u is equal to, by taking e raised to 2u into dou z by dou y as a common. So in bracket we have cos square v plus sin square v. Therefore, x into dou z by dou y plus y into dou z by, sorry, it is v, dou z by dou v plus y into dou z by dou u is equal to e raised to 2u into dou z by dou y. This is the, okay. All are getting it?
Yes, ma'am.
Yes, ma'am.
Now, going for next example. If z is equal to f of xy, where x is equal to e raised to u into cos v, y is equal to e raised to u into sin v, then show that dou z by dou x bracket square plus dou z by dou y bracket square is equal to e raised to minus 2u in bracket dou z by dou u bracket square plus dou z by dou v bracket square. First, understand the given example. Z is function in x and y, where x and y, these are the functions in u and v. And we have to prove that dou z by dou x its square plus dou z by dou y its square is equal to e raised to minus 2u into dou z by dou u bracket square plus dou z by dou v bracket square. Okay. So let us start to solve this example. Just tell me which term we should find first. Yes. Anyone?
Dou z by dou x.
No, it's a wrong.
By do you?
Yes. Z is function in x and y, where x and y, these are the function in u and v. Therefore, here we are finding out derivative of z with respect to u and v first. And at that time, we are getting these two terms automatically. Okay. So don't get confusion. First, we have to find out partial derivative of z because z is a composite function. Partial derivative of z with respect to u as well partial derivative of z with respect to v. So right here, z is function in x and y, and x and y, these are the functions in u and v. So taking derivative of this z with respect to u first is equal to derivative of z with respect to u first. So by using chain rule, it is dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. Similarly, taking derivative of z with respect to v is equal to dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. आता पहिला कॅल्क्युलेट करूयात अगोदर. Finding out the derivative of the z with respect to u. Keep that dou z by dou x as it is because z is given as f of xy into x is given in u and v. So partial derivative of x with respect to u, it is e raised to u into cos v. Okay, plus partial derivative of z in with respect to y and partial derivative of y with respect to u, again it is e raised to u into sin v. Now, what we need here, dou z by dou u, its square. So, squaring on both sides. Therefore, dou z by dou u bracket square is equal to squaring of this complete bracket. Dou z by dou x into e raised to u cos v plus dou z by dou y into e raised to u sin v. It's a square. Okay. So let us start to find out square of that bracket is equal to a plus b bracket square. A square, that is e raised to 2u cos square v into dou z by dou x bracket square plus 2 into ab. So 2 into e raised to 2u cos v sin v into dou z by dou x into dou z by dou y, that gives dou z by dou x dou y. Or you can write it as separately. No issue. त्या ठिकाणी तुम्ही सेपरेटली लिहिलात तरी चालेल तिथं. ओके, आता सेपरेटच लिहिते इथं, परत कन्फ्युजन व्हायला नकोय. Dou z by dou x into dou z by dou y plus third term b square. So it is e raised to 2u into sin square v into dou z by dou y bracket square. Now get back to next derivative. So here taking derivative of z with respect to v first, it is equal to dou z by dou v, that is dou z by dou x into derivative of x with respect to v. What is x here? E raised to u into cos v. With respect to v, it is minus e raised to u into sin v plus dou z by dou y as it is into derivative of v with respect to y. So what is v is given? E raised to u into sin v. So derivative of this term with respect to v, it is e raised to u into cos v. Okay, squaring on both sides. By taking square on both sides, it is equal to dou z by dou v, bracket square is equal to a square. A square, that is e raised to 2u into sin square v into dou z by dou x bracket square plus 2ab. So it is minus a is there. So minus 2 into e raised to 2u cos v into sin v into dou z by dou x, dou z by dou y plus b square. So it is e raised to 2u into cos square v into dou z by dou y bracket square. Okay. Now here earlier we have taken as a first equation and then it is as a second equation. So I am taking that addition of first and second. Adding 1 and 2. Therefore, dou z by dou u bracket square plus dou z by dou v bracket square is equal to. In first equation, 2 into e raised to 2u cos v sin v dou z dou x into dou z dou y. And in second equation, we have minus. So plus minus will get cancelled. Okay. The remaining term we are going to equate. So in first, we have e raised to 2u in bracket cos square v plus sin square v into dou z by dou x bracket square plus second term e raised to 2u in bracket sin square v plus cos square v, sin square v plus cos square v dou z by dou y bracket square. And again here for this bracket we are getting that value 1. Here this bracket, that is also 1. And by taking e raised to 2u as a common term, dou z by dou x bracket square plus dou z by dou y bracket square. आता आपल्याला एक्झॅक्टली काय हवंय हे टर्म इज इक्वल टू therefore dou z by dou x bracket square plus dou z by dou y bracket square is equal to, now we are shifting this term on LHS, it will be 1 upon e raised to 2u, so it is e raised to minus 2u into in bracket dou z by dou u square plus dou z by dou v square. Hence the proof. Do you understand?
Yes, ma'am.
Yes,
Yes.
Ma'am.
Everyone, huh? Bola. Is there any doubt?
ma'am.
No,
Yes,
ma'am.
Aarti?
No doubt, ma'am.
Any doubt? Prithviraj?
Yes, ma'am.
समजलं का?
हो.
So number 5, 6. Okay. I am giving one example for your homework. Just try to solve it. And if you can't, then we will discuss in class. If Z is equal to f of uv, where u is equal to lx plus my, v is equal to L bar minus mx, then find dou 2z by dou x square. There is a difference between bracket square and second derivative. Here it is second derivative now. Minus dou 2z by dou y square. And second term is, we have to find out dou 2z by dou x square plus dou 2z by dou y square. कुणास तर क्युरी होती, कोणीतरी एक्झाम्पल सांगितलं होतं, मला लक्षात नाहीये आता. एक्झाम्पल सुटलेलं नाहीये. कोण पाठवलं होतं मला? व्हॉट्सअपला एक्झाम्पल पाठवलं होतं मला. प्लीज टेल मी.
मॅम
हा,
हा मी पाठवले होते 3 एक्झाम्पल्स होते.
जस्ट टेल मी दॅट, वी विल डिस्कस हियर. आहेत का तुमच्याकडे एक्झाम्पल्स आता?
हो आहेत.
प्लीज टेल मी दॅट.
u इज इक्वल टू
u इज इक्वल टू
2 raised to x
u इज इक्वल टू 2 raised to x. हा
into
हा
sin y into cos x.
cos x और z.
cos x.
ओके. हा फाइंड काय करायचंय?
dou u by dou x काढायचं
dou u by dou x only.
and dou u by dou y.
And dou u by dou y. Okay. हा. Over. Second example.
ma'am.
Second one.
u is equal to
Here it is first one. Second one. U is equal to
y
divided
by x square
x square.
plus y square.
अच्छा, just a minute. Y upon
x square
x square plus y square.
y
Okay.
square.
हाँ.
Find dou u by
Yes.
dou x
Dou u by dou x.
and dou u by dou y.
Dou u by dou y. Next.
Third.
Third one.
u is equal to
U is equal to
e raised to x
e raised to x
into log x
log x
plus
plus
sin y
sin y
into log x.
log x.
Find dou square u
Dou u by
divided by dou x square
dou x square.
and dou square u
Dou 2u by dou y square.
dou y square.
Okay.
Yes.
So go for first one. Here u is equal to, let me write this example as 2 raised to x into cos x. into sin y. Finding out derivative of this u with respect to x first. Here we have 2 raised to x and cos x. There are two terms of x and sin y is a constant. While we are taking partial derivative of u with respect to x, that time y will be constant. So put this y out of that bracket. Taking derivative of 2 raised to x into cos x. Which one will be first? Decide it yourself. Just I am keeping cos x as it is. Into derivative of 2 raised to x. Here 2 is a constant. A raised to x. What is the derivative of a raised to x?
A raised to x log a.
Yes. Instead of that a raised to x, we have 2 raised to x. 2 raised to x into log 2. Okay. Plus derivative 2 raised to x as it is. Derivative of cos x. It is
Minus sin.
sin x. Okay. Which is equal to. Now 2 raised to x you can take as a common term. 2 raised to x into sin y. And in bracket we have a term log 2 into cos x minus sin x. Is it okay? Shruti?
Yes, ma'am.
Next, similarly finding out derivative of u with respect to y. There is only one term of y. So keeping 2 raised to x into cos x constant. And derivative of sin y?
Cos y.
Cos y. Over. Okay. Then, second example. This one is the first. Go for second. U, that is provided y upon x square plus y square. Just look at that. U by v. Means here u is given y upon x square plus y square. And finding out derivative of u with respect to x. Means whatever rules we are using for derivative, simple derivative. The same rules we are using for partial derivative. There are no any changes. So go for that derivative of u y upon x square plus y square. So partial derivative of u with respect to x is equal to y constant upon derivative of 1 upon x square plus y square. 1 upon x square plus y square.
Minus 2x divided by x square plus y square is to.
Yes, minus 2xy divided by x square plus y square bracket square. And next, partial derivative of u with respect to y is equal to. It is minus 2y square. Simply 2y square. No, it is 2y. 1 upon इथे या ठिकाणी आपण आता हे करायला पाहिजे u by v rule apply करायला पाहिजे. Look at this. With respect to y काढतोय आपण. So y into या ठिकाणी u into करतो नाही का? डेरिवेटिव कसं घेतोय आपण u by v rule कसं अप्लाय करतोय?
V constant derivative of u.
First x square plus y square constant. With respect to y, that is 1. It is minus derivative of x square plus y square, that is 2y. 2y into y as it is, divided by x square plus y square bracket square, which is equal to. So काय असेल बघा आता? X square plus y square. No, here, okay. X square plus y square minus 2y square divided by x square plus y square bracket square. So I am taking here, it is equal to x square, y square minus 2y square. It will be minus y square divided by x square plus y square bracket square. Here x plus y, x square minus y square समथिंग गोइंग रॉंग. या ठिकाणी काय मिळेल तुम्हाला 2y. y upon x square plus y square, that is minus 1 upon x square minus y square. X plus y, x minus y. Let me see here. On x square plus y square into 2y, means here it will be 2y upon x square plus y square only. Okay, we will now solve this later on. काहीतरी चुकायला लागलं इथं. सॉल्व करून देते. Attendance please. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 20 21 25 26 27 28 6. Please check out your marks, UT marks, UT2 and UT3. I put it in teaching diary.
मॅम
हाँ,
मॅम
हाँ.
UT2 चे मार्क थोडेसे पुढे मागे झालेत तिथं.
ठीक आहे, मी चेक करते, मला सांगा, मी टाकून देते.
म्हणजे माझे मार्क रोल नंबर 31 ला गेलेत.
हो का?
आणि
ठीक आहे,
मला
मी बघते, मी
21.
ते कुठेतरी ऍब्सेंट असेल मग ते खाली झालं असेल. चेक करते, टाकते परत.
मॅडम
हाँ, yes. I am going to end this meeting here only. Thank you all of you.